AP Calculus, BC, Lesson 9.2, L'Hopital's Rule. It's a lot in this lesson, so we'll pick up the pace just because there is so much, but slow it down and pause if you need to. L'Hopital's Rule is a better way to find limits, and it uses derivatives. A lot of people say, why didn't we do this back in Unit 2 when we were talking about limits, but we couldn't. There's a whole proof for this, which I'm being very, very bad and ignoring, but if you want, you can look it up and check it out. To find the limit, first check if it exists. 1 plus 0 minus 1 equals 0 over 0. If we get 0 over 0, we can take the derivative of the top, 1/2, 1 plus x to the negative 1/2 over 1. Now plug in your 0. Square root of 1 on the bottom is 1, so that would be 1 over 2 times 1 over 1 is 1/2. And it is an incredibly effective way to find limits. Here's the definition. It's basically what I just said, and they've got the whole can't make sure that's 0 if the other one is not, and blah, 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 blah. But the problem with this is there's just a few hundred million things to remember. So always check. Put in 0, we'd get 1 minus 1 minus 0 all over 0. So we take the derivative. 1/2, 1 plus x to the negative 1/2 minus 1/2 all over 2x. Put in 0, we still get 0 over 0. Take it again. Negative 1/4, 1 plus x to the negative 3/2 all over 2. Put in 0, goodbye. We get negative 1/8. I am not going to do it at all, but if you're ever curious, just put it on a calculator and see what happens. That's what we used to do for limits all the time anyway. These are going to be questions you'll see on the non-calculator portion of the AP exam saying, let's figure it out. So you should have memorized this and probably forgotten it. Sine of x over x equals 1. Well, let's do it L'Hopital way. Sine of 0 is 0 over 0. Hey, we can use it. Derivative of sine of x equals cosine of x over 1 equals 1 over 1, 1. Just practice using L'Hopital's rule. Now we get into this, what's going on is we come from left and right, because sometimes the graph is of a function that's going up one way and down another, and we will get infinity as an answer. So for example, here we get 0 over 0. Cosine of x over 2x is 1 over 0. People say, oh, I'll just keep taking derivatives. No, 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 no. 1 over 0 is coming from the positive side, positive infinity, which I just write that way. On the other one, we're coming from the negative side. We get 0 over 0, cosine of x over 2x, 1 over 0 from the negative side, we'll get negative infinity. And we can graph it if we need to, see what's really going on there, but I'm not going to at this time. Again, just to keep life simple. So, be aware. The graph actually looks like this, if that helps. So, now all we got is lots and 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 lots of tricks. These are indeterminate forms of infinity over infinity, or infinity times 0, or infinity minus infinity. We can use L'Hopital with some extra little tricks to do all this. Always check. Secant of pi over 2 is 1 over 0. 1 plus tangent of pi over 2 is just call it infinity. So we basically get infinity over infinity. Take some derivatives. Secant x, tangent x, secant squared x. Now it's interesting because a lot of people get lost at this point saying, well, I got to keep the top and the bottom separate. No, once we've taken the derivative, we're looking for a limit again. So we can make our lives a little bit easier. Sine of x over cosine of x over 1 over cosine of x by. And we're finally down to sine of x, which when we pump in pi over 2, we get 1. Graph it, it'll show you it actually works. In this case, since we have infinity, we have to worry about left hand and right hand. I don't make a big deal about it, but I should. In this case, it doesn't matter. I got a nice answer. The problem is when I get infinity, then I got to stop and say, is it positive or negative infinity? Here again are the possibilities. Here are 3 examples. Put in infinity, we'll get infinity over infinity. Take some derivatives, 1 over x over 2 times 1/2 x to the negative 1/2 by equals x to the negative first over x to the negative 1/2 equals x to the 1/2 over x to the first equals x to the negative 1/2. Can I put infinity in there now? 1 over square root of x. Yes, I can. I get 0. Wow, there's a lot going on there. This is my point. Here, I can do this very, very bizarre trick. I get infinity times 0. So, let's change it. X is going to 0. 1 over x, sine of x. If I were you, I'd pause and let that one sink in. That's like, what? Well, think about it. 1 over 0 is infinity. That's what we got here. Sine of 0 is 1. And that's what we had here, sine of 0. So they are equivalent, but it still freaks people out a little bit. But the reason we did that is now we can write this as sine of x over x. Take the derivative, cosine of x over 1. As it goes to infinity, oh, sorry, now we're going to 0. We get 1. Now, like I said, we have to worry about negative positive infinity if we're going to infinity. In this case, we're not, so we're just going to get 1. All right, it's the exact same deal. If we were going to infinity, we'd have to worry about negative and positive infinity. Not in this case. What's up with this? 1 over 0 minus 1 over 0. That kind of stinks. So we don't really have 2 functions. Let's get it. So we have a common denominator. X minus 1 minus natural log of x all over natural log of x times x minus 1. If you're crying at this point, so am I. This is a hassle. So we've got to take some derivatives on the top. That's actually not too bad. 1 minus 1 over x. Derivative on the bottom. First one, leave it alone. Second one, leave it alone. I'm a neat freak. My apologies. Now we're going to 1. Top is 0. Bottom is 0 plus something we can't get. So what do? Derivative again. On the top, I guess we should simplify this and see where it takes us. We did get 0 again. We're going to have to take the derivative. Before we do that, let's make the top x minus 1 over x. Let's make the bottom x minus 1 plus x natural log of x over x. They cancel. X minus 1 over x minus 1 plus x natural log of x. Making sure I did this right. Hey, no mistakes for a change. Shocking. Derivative. Running out of space. 1 over 2 plus natural log of x. Check that out on your own. I'm out of space. Plug in 1. ln of 1 is 0. We get 1/2. Double derivative. Lots and lots of messy stuff going on there. Now, I missed this one the first time I did it. There are 3 cases. Notice that 0, pardon me, one of the zeros not in that list. Notice that, what was the other one that got me? 0 to the infinity is not on that list. So if you see these and you can't mess with them, you're going to have to do something different. These are the only 3 cases it works for. And use a natural log property, which seems extremely illegal, to put it simply. First things first, we get 1 plus 0 to the infinity, which is 1 to the infinity. There it is. So we can rewrite this. Natural log of 1 plus 1 over x. You might be saying you can't just take the natural log, and I'd say I agree with you, but trust me, it's going to work out for us. So we need a function on top and below. I don't know. What if we just left the natural log of 1 plus 1 over x and rewrote the x as 1 over x? Would that work? Hint, hint, yes it would. Keep it coming all the way over here. Take the derivative. 1 over 1 plus 1 over x times, I want to make sure I don't screw this up. Derivative of this piece is going to be -1 x to the -2nd. Same thing on the bottom. -1 x to the -2nd. Oh, look at that, they cancel. We end up with 1 over 1 plus 1 over x. If I put an infinity in there, I get 1 over 1 plus 0 equals 1. You think we're done, but we just took this random natural log. We can't just do that. We have to now say undo that by going e to that 1. So that's our answer, e. A lot of work, a lot going on there. Watch out. Does this limit exist? We get 0 to the 0. Was that on our list? It was. Second one, 0 to the 0. So, natural log, x goes out front, rewrite it. Derivative, 1 over x over -1 x to the -2nd equals 1 over x times -x. I gotta rewrite this. I can't do this one quite in my head. Flip it and multiply. X squared over 1. Cool. See ya, equals -x. X goes to 0. I get 0. Done? No. E to 0 equals 1. That's our answer. Wow. Even I get a little bit like jaded when I blow through these. Like, you gotta be kidding me. That's it. It's a lot going on. X to the 1 over infinity. Infinity is infinity to the 0. On the list. So 1 over x, natural log of x, it's already set up. I don't have to do that little trick I showed before. 1 over x over 1 equals 1 over x. X goes to infinity, we get 0. E to the 0 is 1. Or you could just graph it, which is something I would recommend. So, just a few thousand different ways to take limits. Practice, 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 practice. It does get easier. And as in all things, happy mathing.